In this video, I want to talk about what an atom is made out of. And if you guys remember my last video, I talked about how everything is made out of atoms. And these smallest particles, they look the same, however, they might not be the same element. And how do we distinguish all these elements is because of the number of protons that they have. Now, what are those protons? Is that something that an atom is made out of? Well, it turns out the answer is yes. But protons are not the only element, the only particles that an atom is made out of. There are a lot of other particles that are inside an atom, and I'm gonna tell you about three major particles that are inside the atom and three major particles that you need to know for general chemistry. Well, how does an atom look like? Well, in classic chemistry, the way they explained an atom was by a dot or just a point. Now, I'm going to use the same idea because back in the days, they didn't have microscopes to basically look at what an actual atom looks like. However, because we did this before and that's how people learned it, I'm gonna teach you how an atom looks like using the classic theories. And if you want to look at what an atom looks like in real life, you can just go and Google it up. But this is how I learned it, and that's how I want to teach you. Okay, now an atom, let's say it's a point, and whenever we want to look inside an atom, we have to put it inside a microscope or put it in the bottom of a microscope to look at it. And because we have an atom, let's say we put it on a microscope, it shows us a circle and something inside, another circle that's inside. Well, it turns out the smaller circle is the nucleus of our atom, or the nuclear. They call it a nucleus or a nuclear at the same time. And there's this bigger circle that's there, and we're going to talk about what that circle is. And if you're wondering, it's just an orbit, but we're not there yet. But I am going to start talking about nucleus first, because inside this nucleus we have two different particles and particles and two different particles. And these two particles are protons and neutrons. Neutrons, okay. Now, as I told you before, proton is what makes all of these atoms different. And neutrons are there, it's because of the atomic mass, but we will talk about that later. Now, in the orbits, or in our orbitals, we have electrons. Now, what are these things? These are just small particles like protons and neutrons, and the only thing is that the charge of electrons are different. That's why they're outside of the nucleus and they locate in the orbits. Now, what are the charges of all these particles? Well, it turns out there has to be some kind of charge to put them in their places, meaning that protons, they should have some kind of charge to put them inside a nuclear, and electrons, they should have some kind of charge to put them outside of that nucleus in the orbits. And these charges, they might not make sense to you right now, but as we go and talk more about general chemistry, we will know that why do we actually have these charges and how are they going to help us with everything. But for now, all you need to know is that protons are positively charged and their charge is positive, and electrons, they have negative, they have a charge of negative, and the fact that they're in their places is because of the fact that we have opposites attract. And because electrons are negative and protons are positive, they are going to have this kind of attraction between them, but they're never going to touch each other. They will have that force or that power inside of them. Like they will be, if they wanted to, they could just go and collide with each other. But because opposites attract and we have orbitals, then they cannot be together. Now, protons are positive, electrons are negative. What about neutrons? It turns out neutrons do not have any charge. Neutrons, their charge is zero. Their charge is zero and they're not going to have any charges. The only thing that neutron will affect is the atomic mass of an atom. It's not going to affect anything else. We will have isotopes with neutrons, but we will talk about it in later videos. But in this case, I just wanted you to know that protons are positive, electrons are negative, and neutrons are don't have any charge. They're zero. Okay, how do we find the number of protons and electrons and neutrons in an atom? Well, whenever we have an atom itself and an atom that's in nature, the number of protons and electrons are equal to each other in nature. And instead of protons, I'm going to use P. And instead of electron, I'm going to use E. And I'm going to put the charges on top of them, positive, negative. In nature, protons and electrons, they are equal to each other, meaning that if I have 10 protons, I should have 10 electrons. Neutrons, we will use atomic mass minus number of protons to find the amount of neutrons in an atom. And how do we basically find that is, how do we basically find the number of protons then? The number of protons, as I told you before, is the atomic number of an atom. This is the atomic number of an atom. And the easiest way to find it is to have a periodic table and look at the atomic number of an atom. And you're not expected to memorize all these because you will always have a periodic table with you, and you will always have the atomic number of an element with you. Let's start with an example. Let's say we have the atom helium, and helium has an atomic number of 2 and an atomic mass of 4. I'm rounding my numbers, and if you want a video about rounding, I can make one. But yes, the atomic number for helium is 2 and the atomic mass is 4. And our question is, what is the number of protons, electrons, and neutrons in this atom? Well, the easiest way to find it is basically look at the atomic number. And we know that the atomic number is equal to number of protons, which means P positive is 2. And we know that protons and electrons are equal to each other. So number of electrons should also be 2. Now, what about the number of neutrons? That's when we use the atomic mass. So we know that the atomic mass for our helium is 4 minus the number of protons, which is 2, and 4 minus 2 is 2. So this is the number of neutrons, which have a charge of 0, or I can just write it like this. It can be that easy. Well, let's say in some questions they might give you the number of neutrons and number of protons, and they might ask you about the atomic mass. In that case, you have to remember that electrons do not have any mass. The whole mass that we see, the atomic mass that we see in an atom, it's only made out of the protons and neutrons that are inside the nucleus. And electrons, they have a mass, but the mass of an electron is really small, that we basically neglect it most of the time. But there is a number for that. I think it's 9 point something times 10 to the negative 36, which means it's like really small. That's why we don't have it in our atomic mass. But if they give you the number of neutrons and number of protons, you just have to add them up to get the atomic mass. Now let's say we have another element, magnesium, with an atomic number of 12 and a atomic mass of 24. How do we find the number of protons? Well, the protons, we said that protons are equal to the atomic number, which means my protons should be 12. And since this is in nature and magnesium is in its natural form, the number of protons and the number of electrons should be equal to each other, so we know that the electrons are also 12. Now, how do we find the number of neutrons? The only thing I need to do is 24 minus 12, 24 minus 12, and we get a 12, which means the number of neutrons, which has a charge of 0, is equal to 12. And that's it for today. Thank you.